I think I'll start with that. Most of us who are here right now are mostly using Jupyter and VSCode, and mostly we are creating one-off scripts for your experiments, and or creating like a full projects with these IDEs. So like properly organizing your scripts and everything. Okay, thank you. I'll share my screen here. There you go. I hope everyone can see my screen, and the Zoom button will trouble me a little bit. So, all right. We'll start with Jupyter first, and we look at what Jupyter provides us. Maybe you've already been using Jupyter, and this is like this session doesn't provide you much information about new things about Jupyter already. People get confused about Jupyter Lab and Jupyter Notebook. So I just want to clarify here that Jupyter is like an umbrella term. Jupyter Lab is what is like a big project in which Jupyter Notebook is a part of. And Jupyter Lab is, if you already saw in the previous session, we saw Jupyter Lab. It's what is like a web browser for your notebooks. And Jupyter Notebook is in which you are actually doing your coding. There's another word which gets thrown around, which is IPython. Here, IPython is the kernel itself. So IPython means interactive Python, right? And we call it like IPyKernel sometimes. So IPython is like the Python backend with which you can interact with the Python script interactively, like cell by cell. So think when the Jupyter was getting developed, IPython was also getting developed side by side. But now IPyKernel, with which you can like interact with your Python scripts, can be used in other IDEs as well. Jupyter in itself is pretty simple interface than the Spyder and then the VSCode. So mostly if you're like creating one-off scripts, you usually land up in Jupyter and you're working with Jupyter notebooks. And .ipynb is what the notebook extension is called usually. So I have here, I'm using Pele right now. This is my Pele interface. And I'm running a Jupyter Notebook already. I'm running it on login node right now, just to give you a small demo. And like usually if you're doing like very small tasks or very lightweight coding, you can use the login node itself. But if you have to do heavy complex run of your scripts, then it's better to run like compute nodes then. In this case, this is just login node. And here, let me see if I can minimize this thing. And this is where you will usually land. On the left side, you will see your the files where you started your Jupyter server from. So I started my Jupyter server from the Pele's, the project that we have, that folder. And I have only like 2 files here, so I can only see 2 files currently. And on the right side, you'll see all the applications that the Jupyter Lab can provide, but the default one, which comes with the Pele, is only the IPyKernel and the console here. And these are some extra stuff that I personally have never used. Terminal, simple markdown file, normal file, and stuff. So if I open one of my files here, so you can already see this looks like like this launcher looks like a web browser itself. We have tabs and everything. And these are like the cells here. And these cells are like 2 kinds. One is the code, one is the markdown. So if I double click on the first one, I can edit this and it says markdown here. So I identify this cell as markdown. it's pretty handy to like also learn some shortcuts and commands, how to like switch between the type of the cell, between markdown and the code cell. So for that, I have given some shortcuts in the documentation itself. You can click Control M for Markdown. It converts to Markdown. This one is already there. Or Control Y, and that converts into the cell for the code. Then this particular cell is for the code. And you see, if you run this particular one, this outputs its intermediate output in the next line itself. So I can run this cell like so, and this is the output for that one. Of course, I can also delete all these outputs here. You can clear outputs, like you can go to probably it's thing. Let's see, it's maybe clear. Maybe in the edit. So we have clear cell output, and all this cells can be also cleared, of course. And you can also have your LaTeX running here. So if you have like math equations, you can also run LaTeX commands here. So this is pretty handy if you're using like one-off scripts, because you have just one script in which you want to like also do some ideation and also code in the cells, and just run one at a time. Another useful feature of Jupyter notebooks are these magic commands, which starts with these percentage signs. So ideally, they should be on the first line of the cell. And if that, so these commands are, if there are like 2 percentage signs, that means it is meant for the whole cell. If it's just 1 percentage sign, that means it's meant for just that particular line. For example, this one is called time it, which times how long this cell executes for and gives an average of that. In this case, I'm just summing first 1,000 numbers, and it gives me 10 microseconds plus minus this many. And you can see it's trying to like average it for like 100,000 loops. So it doesn't make sense, of course, like to use this particular command for a cell which takes 10 minutes in the first run itself, because then it will keep running, right? So there's another command, time, for that instead of time it you can use. Then there is another one called whos, which is basically printing out all the variables that have been like executed before this cell, and their data types and these values. So we ran A and B here, and you can see the values here. Then these are pretty handy. You can already run like some terminal commands here directly through Jupyter Notebook by giving amp like exclamation mark. So I'm running this one, exclamation PWD. It gives me the what PWD should give me, and ls minus l what it should give me otherwise. You can also do, by the way, pip. So if you want to like, oh, I forgot a like library, I need to like install that library, you can also do pip install here. So like this, pip install. Let's say you want to install transformers, and then you hit run. Although the Jupyter, they say that it's best to use %pip, because this is also one of their magic commands. But it doesn't matter. You can also use exclamation pip, although the ampersand one is recommended. And of course, like plotting and everything, you can do. We'll also cover matplotlib again in tomorrow's session. Matplotlib inline, and then you can see the plots here itself. I have not switched kernels, but maybe you can also switch kernels and find kernels here. I'm not sure. I don't usually do that. If I'm building an environment, I already have my Python Jupyter kernel there and other stuff already in there. And I just refresh that environment. I feel that's the best way to go with that. And you can check what kernels. So for example, so this kernel is running and this notebook is already running. You can, of course, stop this kernel. You can restart this kernel in case you want to. You can also check what all kernels are running. On the left side, you can see, for example, in this tab, it will show you, okay, this particular notebook is already running. You can, if you want, you can click kill it as well. So this was a very brief overview of Jupyter, and we are a little bit already over time because we had a break here. But I have given some shortcuts. These are useful shortcuts that I myself use when I'm using Jupyter. I find it pretty useful. And some magic commands. I don't use them very often, but sometimes I do use them. So you can have a look, and maybe if you're using Jupyter, you can use them. This is the code that I was demonstrating. You can type it out and also try it yourself. So now we'll take a break. Let's see. We are slightly over time already. Maybe we can take a break for, we can return back by 3:15. I'll stop sharing. 15, we can start. So now it comes Spyder, which is a slightly more enhanced and gives more functionalities than just Jupyter. But I'm guessing because no one is using Spyder in their day-to-day work in today's session, I'll just quickly go through Spyder instead. So if your work consists of like a lot of visualizations, I think Spyder is a really good one to use. And it's slightly more or less like Jupyter Notebook in the sense that you can also use like create cells and see good visualizations, but you can also have like a lot of configurations that you can do with it to make sure that your visualizations are good. So this is how the Spyder IDE looks like. On the left side, you have the editor itself. On the top right, you have some helpful tools like the variable explorer, a debugger to see the plots, to see the files. And on the bottom right, you have the kernel, IPython kernel console, I mean, on the kernel. And that means you can, of course, like also give command, some Python commands here, and you can also explore some variables here. But I guess this top variable explorer is a better option in that case. So we are looking at a very simple sample script to just see what this Spyder provides us with. This script doesn't, by the way, has any plots in it, but it did. If it did, you can see it in the plots section here. And as you see, there are like horizontal bars here, so that these are like the cells. And you can create cells by giving, again, like ampersand, ampersand, like this one. And then that will like create another cell underneath it. So hashtag ampersand, and then it will create a cell. And then just like Jupyter Notebook, you can run these cells individually one by one. So this one lets you, like this button lets you run each cell individually. So if I run just this one, this console will say, okay, this just ran this particular cell, and that's all. Whereas I can also run the whole script like this. So if I click this button, it should run all the cells together. So this one is running for some reason. It is slow. I'm not sure why. I just deleted the variables that I was having earlier. Let's hope that, yeah, there you go. Okay. Yeah, so you see all the variables can be explored here. For example, I also have a class here called counter, and I created an object CTR here. So let's see if I can just run this particular cell. Yes, and then you see the variable appears here with the type counter class. You can click on this class, and then you can further explore its methods. For example, this particular one had an internal variable called value, and I gave 5 to the counter initial, init, and called the inc method, which increments it by 2. So 5 plus 2 is 7, and then you see 7 as a value here for that particular variable. So this is pretty handy if you have like very large classes and you want to see what's going on, what are the values of these variables inside it. And on the console, of course, you can also like, because this is the IPython console, it's interactive. You can say, let's say I want to see what is A. So if I do A, then it says, okay, this is 10. I can also use it like so, and then it will be used. Okay, so I think I can just skip over many of the configuration settings for Spyder because no one else is using in this session. But just to recap, if you have like work which requires a lot of visualization stuff, I think Spyder is a better place to be and use Spyder instead of Jupyter sometimes. In the Spyder documentation, you can see some quick tips, what can be used where. So for example, if you need to like improve the DPI for your interface, or if you want to make the plots look better, there are some configuration settings available for Spyder here. I was using this particular script, which is like a sample script that you can just copy paste and also play around with. And I was running my Spyder on Pele again. And this of course required, as you see in the previous session, I had to create a environment. In my case, I created a Conda environment and ran my Spyder, installed Spyder in it, and that's what I started. Okay, so lastly, the VSCode. I think VSCode is the most popular one and it's the most richest in functionalities, and it has been on the top when like new functions have to be like pushed, even like with AI Copilot and everything. VSCode has adopted AI very well, and I personally use it. Just a second, I need to refresh my, yeah. I personally use it, and for like, if you have like large projects and you have a lot of scripts, then it just makes sense to just keep using VS Code in that case. But if you're like using and other IDEs like Vim, then I don't think you might not be even in this session then. With a lot of like features in VS Code, of course, you have to like be acquainted with it. You can also like learn some shortcuts to use. I think it's pretty handy to know like some shortcuts that you can use with VS Code. It makes makes you very proficient while using the IDE. Okay, so I have started a VS Code. This is my personal VS Code, which is on my local laptop. And if anyone else is interested in it, you can also start your VS Code, and then we can try to connect to one of the whatever HPC you are in, and then maybe run a script there. But otherwise, you can just see my demo here. It looks almost similar like Spyder in the case that you have an editor. On the left side, you have the file explorers. On the extreme left side, you have some widgets, some other functions that you can use. And on the right side, well, this is new. This is maybe only for me because I'm using Copilot as well. Otherwise, this might not be visible to you like that. And on the bottommost one, it says things like, okay, if you're using some, if I'm SSHing to a server, it will tell me, okay, you are already connected there. Bottom right, it says what kind of interpreter you're using. You can select an interpreter from this one. I think it does a pretty good job if it has to like search for interpreters also, also on the remote side. So in this case, now I've just for the sake of diversity, I've started Tetralith, and I'm connected to Tetralith here. And you can see like I have a script here, which is like a very basic one. It's again in the documentation, bottom one, but just to show that I can connect to Tetralith and I can run my scripts. So, well, it says like there's a warning sign here. So I need to first, of course, look for the kernel. In this case, this is .py. So I need to have a Python interpreter in this case. So I'll search for the Python interpreter. Just maybe. Yeah. So here I can enter my Python interpreter. Now I know like I created a environment that is called VSC underscore VENV. Maybe you also have one of your environments somewhere that you created and pip installed all your dependencies and libraries there. So I need to find my VENV through this one. In this case, there are well many ways. First of all, I know that this one is lying in this part, which you can see when I hover on it. Proj courses fall to 2025 users. So I can perhaps give that one. I can also copy my path here instead. Okay. Let's see if it's able to. Yeah. So it detected that I had a Python 3.9.21 here, and it already connected it that particular interpreter with this particular file. Maybe I should make it a little bit bigger so that you can see. Yeah, so 3.921 is what I'm using, and this VSC underscore VENV. And then just like any other thing, I can just run this file. This particular IDE also comes with its terminal. So sometimes I don't even use my other terminal. I just use VSCode and its terminal, and I do everything from VSCode. Let me just. So this particular file ran. I gave the output. I had in my environment some other libraries like NumPy, SciPy. But then that's not it. You can also have your. Okay. I hope I'm still in the call. You can also connect with your Python kernel, IPy kernel. So in this example, I have my IPyNB notebook here, and I would like to run it on I would like to fetch my kernel from, in this case, Tetralith. So I'll do that now. Uh, and I have, let's see, get my name, the project. see, for 1 hour. And in this case, I really don't care how much core I'm using. I'm just running a very simple stuff. So I'm just going to hit enter and hopefully I'll get a node quickly. So, okay, I got a node N617, and now I will, hopefully I'm still on my correct path. Yes, I'll just go to my folder here where I have my VSCENV underscore VENV. This is also having my Jupyter kernel. So I'm going to run my Jupyter notebook. And we already saw how to run this in the previous sessions. I'm just using the same commands. Uh, for that, I need to also activate my now it's activated, and now I can start my Jupyter notebook. Okay, so my Jupyter server is running, and in a moment it will give me the URL that I need to use as where the server is. Now remember that I have already SSH'd my VS Code into Tetralith. So I'm right now, I am on the login node itself. So if I, in this case, just copy my URL here, which is, where the node is with the port and the token. I can go top right. I can select existing Jupyter kernels. I can paste this URL, and it usually says, okay, connect to Jupyter server. I click on it, and it says, okay, this is the sort of the node. I just hit enter and says, okay, yeah, there is an IPy kernel. It didn't identify it. I click on it. And then you see that this has connected, and it also on hovering shows this is the host name. So if I run this again, let's see if I can run all the cells actually. This particular is, yes, the host has changed, which is 617. I said which Python. It gives me the Python from where the kernel is residing in, which is the VSCENV. And the same script which you saw earlier, but this time on a compute node. And this is the output for that. And in another cell, I'm also running something which is based on Jupyter, on GPU. It requires GPU. Well, I didn't ask for a compute node with GPU, but anyway, I'm just running it for the sake of running it right now. But if you have a compute node with GPU, then it will fetch the GPU in that case. And this particular cell is running. And this is basically running a transformers, and this is running a model called BERT-based uncaged model. So it's a transformers model, and it's trying to tokenize using that model's tokenizer. The transformers library is amazing, and it tries to tokenize it. Okay, so it's still running, and it takes a while, but maybe it will run in some time. Meanwhile, I can just comment on a few more things here, or a few more functionalities of Jupyter Notebook. If you have like big projects, then you can source control it. That means if it's a Git repo, then you can Git control it from this particular one. You can install more extensions using this one. You can search more extensions. I've given some recommended extensions to start with in the documentation. That extension also includes a remote explorer through which you can SSH to these remote HPCs that you are on. In my case, I've SSH to all of these. And then this is for Copilot. Pretty useful search feature here that I use very occasionally when my code base gets very, very large. I can search within the files for functions, for variables, for the name of the files as well. And now there is also an AI search feature which appears when I start searching. It does a different kind of search, perhaps. I don't know how. In Spyder, we saw there was a history. In this case, there is a timeline for the VSCode, which gives the back history of like what you did, what commands you hit, and everything. So our code has run now. It took some while because it's a big model. But in this case, the GPU was not available. Of course, I didn't ask for a GPU node, compute node. But it found CPU and it ran the CPU and it did its thing. It de-tokenized the text. You don't have to understand what exactly this code does, just for the sake of running code on a compute node, that is. And yeah, so this is how you can switch to different kernels onto another compute node. And this is where you can see your terminal. You can also see there's a port here. So VS Code also port forwards your remote server that you are trying to connect with. So in this case, I am trying to fetch this IPy kernel. It also already port forwarded it. And if I click on it, it will open the same Jupyter lab on my Chrome here. It asks for a token. I can copy that token that we already had previously from the URL. So it's just to say that it can port forward automatically and also let you directly control, like see what the output is into a proper Jupyter notebook. If you're using other, not Python, but other things, of course, there's also an option for like preview, and then you can preview what kind of output there is to this. And you can split your editors, which is very useful if you have like very, very long codes, and you can like compare and code in that sense. I don't usually use this particular feature unless if I'm using a Vim editor. So hopefully this should close. Yeah. Okay, I'm gonna save this one and we still have some time left. So let's see, where are we? Until 45. So we have like almost 10 minutes left. So I'll just let everyone use their favorite editor. And if they have any questions for me, I can go through them again.